In this example, we're going to run through 4 different systems of equations, and we're going to graph each one of these. One of the things that's nice to be able to do is to change each one of these linear equations, or equations that will work out to be lines when we graph them, is to change them into slope-intercept form. So to do that with the first one, what I'm going to do is I'm going to subtract 2x. So I'll have negative y is equal to negative 2x minus 5, then divide by negative 1. When we divide by negative 1, every single sign is going to change. So this equation here is actually y is equal to 2x plus 5. If we graph that, it's going to look a little like this. Slope of 2 is up to right 1 or down to left 1. And we can keep going, and we'll have a nice line here to base our thoughts off of. Alright. So let's see, there's that and that. It's a little bit light and green there, but I think you can see it. And then we'll do the same thing here, except this time we'll have to add 2x to each side. So we'll get negative y is equal to 2x minus 1, divide by negative 1, and we get y is equal to negative 2x plus 1. So there's our y-intercept of 1 up to left 1 this time, or down to right 1. And we can actually see the intersection point right now. So this is enough for the graphing section. And we can just draw our straight line here. And we can see that the intersection is going to be at negative 1, 3. And that's the answer to this one over here. We want to check this one. So I'm going to use the 2x minus y is equal to negative 5. That'll be 2 times negative 1 minus 5, minus 3, excuse me. Our y value is 3 here, is equal to negative 5. So negative 2 minus 3 is equal to negative 5. This one checks, at least for the first one. For the second one, we want to go right back to the original here. So that's negative 2 times x, which we think is negative 1, minus 3 is negative 1. Negative 2 times negative 1 is positive 2, and 2 minus 3 is negative 1, so that one's checked as well. For part F here, at first glance, it might look a little tricky, but this is actually a very easy system to solve. They kind of tell you what each one is right now, so you could even guess and say, well, the solution to this must be negative 3, 5. X is negative 3, y is 5. Well, you'd be right, but let's graph it and see how it looks. So x is equal to negative 3, we'll do that in the first one. That's just a vertical line passing through an x value of negative 3. And then y is equal to a number is a horizontal line passing through a y value of 5. And you can see here that our intersection point is what we thought it was originally, negative 3, 5. And so even if we have vertical or horizontal lines, the intersection is still the solution. Now as far as the check goes, I mean, negative 3 is equal to negative 3, it's checked, and then 5 is equal to 5, that's checked, and we're good to go. So let's move on to G and H. And in G and H here, we actually, each one of these lines that we're seeing is already in slope-intercept form. Sweet. So just to graph them here, the first one, we've got a y-intercept of negative 7, a slope of 1, so that's up 1, right 1. It's definitely positive, so make sure that from left to right, your line looks like it's going uphill. And we could just make it a little more precise here. There we go. So all we need to do now is just use a straight edge and draw this line right here. There it is. And then we'll try to do the same thing with the next one here. Y is equal to negative 1/4 x minus 2. So there's your y-intercept. Your slope is negative 1/4, so that's down 1, right 4, down 1, right 4, or up 1, left 4. And we could continue, but we already have found it looks like that intersection point. So at this step of the game, it is enough to just connect those up, and we can call it good. Except for the check. We absolutely need to check here. So this point here is 4, negative 3. I'll put that right here. That's the solution, at least we think. But if we've made a mistake graphing, the only way to check this is to actually plug these values in each equation and make sure that it works. So y is negative 3, x is 4, And 4 minus 7 is negative 3. So this one's checked. I should have done green with that one, sorry. You'll have to excuse me here, this should have been green. That's the first one. This is our first equation, trying to go with a little color scheme here. But the next one, we could also check this one as well. And so we've got y, which is negative 3, we think, is equal to negative 1/4 times x, which is 4, minus 2. And negative 1/4 times 4, or 1/4 of 4 here, is going to be negative 1. Minus 2 is exactly negative 3. So that one checks as well. We've got one last one to do here, and this is part h. So we've got a y-intercept of negative 4 with this one, a slope of 2, up 2, right 1, up 2, right 1, and so on. It's nice to be very precise, and we can continue these. It doesn't take that long to be just a little more precise. And sometimes we really need that. Let me get this purple marker out of your way. That would be a good thing. And let's see, we'll just draw this line right here. That's our green line, the first one. And then the purple is going to be our second one. So we've got y is equal to negative x plus 5. Y-intercept of 5. A negative 1, slope of negative 1 is just down 1, right 1. It's going to go right through the diagonal of each one of these boxes. And I'm just going to stop there because we found what we needed to. We've got that intersection point, which is the big thing for a system of equations. We want to find that intersection point. And the intersection here is at 3, 2. There's 3, 2, and we'll substitute this into each one. Let me try to use the correct color for you. We'll do the first one. Remember, y is 2 here. Common student error is to choose the first number for the first variable, but y is the second variable in the ordered pair here. So we have to write 2 is equal to 2 times 3 minus 4. If we do a little bit of order of operations work on the right side, we've got 2 times 3 is 6 minus 4, and 6 minus 4 is 2. So that one checks. And hopefully the second one checks as well. Let's see if it does. 2 is equal to the opposite of x, which we think is 3 plus 5. So 2 is equal to negative 3 plus 5. That is also true. And we are all finished.